This is going to be a little all over the place, but I'm going to, today at least, I'm going to want to collect some information, be it some measurements as well as some practical experiment. So I guess I should maybe take a step back. I'm writing a research paper on sort of this argument between Phillips head screwdrivers and JIS head screwdrivers, which even from the get-go is kind of a flawed argument, since putting it most generally, all JIS head screwdrivers are cross-tipped Phillips, but not all Phillips are JIS. And that sort of brings into the world of industrial standards what does the name Phillips actually mean and how it really has no relevance anymore. The name Phillips doesn't mean anything. It's just a colloquialism for crosshead screwdrivers, which really doesn't tell you more beyond that. Since there are things like industrial standards, various like tip geometries, which is why JIS has become so popular because of how it has a more, I guess you could say, broader tip geometry, so it's able to sink into screw heads a little better than Phillips, which are a little more pointed from what I've been able to determine. And there's this idea floating around that Phillips heads, as are called generally, will cam out on screws. And though some will say that is intentional, there really isn't any data to back up that theory. Or not so much there's no data, there's plenty of anecdotal evidence, especially from like motorcycle circles, from people working on like old Japanese motorcycles. There's enough anecdotal experience to call into question whether or not that was legitimate. It could also be just because they're using the wrong size screwdriver, but the amount of anecdotal experience does not lend credit to that idea. If it was just a few people using the wrong screwdriver, that's one thing, but when it's groups saying, yeah, this happens, I had to modify my screwdriver in order for them to fit type of deal. So what I'm wanting to do is actually look at these two screwdrivers that I have, which this is sort of a random name brand Chinese like precision screwdriver set. Well, I guess I can't say no name. It does have a name, and apparently they do have a website. This screwdriver kit has been very good to me, so I'm not trying to like belittle it by calling it Japanese or Chinese garbage essentially, but when I tried looking up what this tip was, other than just being labeled as Phillips 00, which I guess I can just bring that underneath my microscope because that will be much easier to see. Other than just being labeled Phillips 00, there's also these two other markings, CR-V. I actually don't know what that means either, but I'm more focused on this. It's just calling it a Phillips 00. I can look into those letters later. So, again, this just being generally called Phillips doesn't really tell me anything about the tip geometry other than it's a cross tip. And then I have, well, what's supposed to be a vessel. I think this thing's a knockoff. I got this thing from AliExpress, but all of the lettering wiped off very easily. I ended up just carving PH 00 into it so I'd remember that this is a 00. But according to what I've been able to find, this is quote unquote a JIS head. So I'm trying, and then I also have a bunch of these like pack-in screwdrivers that I got from different shell kits. I think there's one. I think I might have a couple 00s in here somewhere, or I don't know. Either they didn't come with lettering at all, or the sort of sizing guide on the sides of them don't really make any sense. Like, what does 360 times 50 mean? This one has calling it a 1.5, but that head doesn't really line up with a 1.5. Because I mean, I think this is a 0. Here's a Phillips 0, and here's a 1.5 apparently, which, yeah, it's not a 0. It's not a 1.5. Because then you get to a thing like a 2, which is the biggest one in my kit that I have. Getting a little beyond. That's a 2. So really what I wanted to do was just measure the tips with some calipers, try and get the best sort of measurements that I can. I wanted to look at the camming out behavior of a Phillips driver. I am speaking in a lot of air quotes because, yeah, it's complicated. It's very complicated. But I'll trying to see if I can replicate a cam out on this piece of this old DSI shell that's busted, so this thing's garbage. And then I'll try and see if the two performance of these two 00s are the same, or if there is this camming out behavior that's been observed with motorcycles. And I also have to take into consideration that not only is we're in the 2020s, I'm not working on equipment from the 1970s. I'm also dealing with fairly modern screwdrivers. Like, I didn't buy these things super long ago, a few years at least. So it's not like I have like 30-year-old Phillips drivers kicking around that I'm using for this project. These are all relatively modern. And I'm also working at a small scale. I'm working on like 1.6 metric screws, which are incredibly tiny, and I don't think they have those in the motorcycle world. I think a lot of the sizing I've seen were like number 2 and higher screwdrivers. In that range, number 2, number 1. So the screw head geometry on screws this small might all be JIS, to put in air quotes, in just sort of how that geometry is structured. And that, like a normal Phillips geometry, broadly speaking, of the more pointed head that has the tendency to cam out, is not applicable to screws this small. So the general standard for anything 00 or 0 and 00 or even 000 are going to be more pretty much the same. Yeah, so it's complicated. It's very complicated. And then you throw in the problem of not being even able to look at the standards because you need to pay to look at the standards. Yeah, okay. So I'll stop babbling and actually get onto this. So generally speaking, when I look at these two heads, they are different. So the lot of the images I see for JIS and Phillips screwdrivers are the JIS have sort of a shorter wingspan to them. These are both 00s. So they should be the same size. Right at the tip you can tell that they are the same size. It looks like this what should be JIS, which I don't know what standard Vessel follows, but Vessel has been touted as like the JIS screwdriver to get. What's interesting is my Phillips is a lot smaller, or this Vessel one is definitely a lot wider. That shouldn't matter at the tip. At the very tip of it, it shouldn't matter, so to speak, as long as the angle of approach is the same. Like, if the first, like, millimeter of this screwdriver head is the same on both screwdrivers, they would both function the same. The Vessel theoretically would be able to perform on larger screws, like number 1. Well, not number 1. Actually, maybe no, maybe not that big. But it flaring up that large would be able to give it an option to work on larger screwdrivers. So I wanted to just sort of try and take some approximate measurements. These are not going to be accurate, and I really don't like that I can't take accurate measurements, but this is kind of what I'm working with. I'm wanting to grab the length of that. I'm going to go in millimeters. because I can plug measurements into AI to determine how big everything is or what the angle is, because I'm not going to try. I'm a little removed from geometry. And the angle of the slope, or like the angle of like a trapezoid, I'm not going to try and figure out. About right there. Using measurements from my microscope also induces flaws, because if my microscope is off just by a little bit, I don't want to produce false results. But this is a little better than eyeballing it. Gotta get an angle kind of matched. That's about the length of this wing. I think they're called vanes. Which is about 2 millimeters on the dot. So I'm just gonna draw a trapezoid. I'm not gonna try and do a sketch of the screwdriver head because I'm not artistic in the slightest. So I want to get the actual head. This one's gonna be a little tough. I might be able to just do it by fitting in the grooves of this drive. No, I think it might flare out. So I'm gonna have to sort of do an approximation again. So I'm gonna want to get to the very tip without being influenced by the sloping of the vanes. Go a little further out. This one is gonna be a sub-millimeter measurement. A little further in. Too far. It might be 0.6 millimeters. I think that's kind of where I'm hovering. Yeah, I like 0.6. And then I want to do the base of the wings. That will be like right here-ish. It looks like it's parallel all the way down. I'm sort of sliding my calipers, so I can just do a diameter measurement, which is about 2.5. So then the angle of a... So then I need to figure out what this angle is. Again, I'm very far removed from geometry. I'll just let AI do this measurement for me because I wouldn't even know where to begin with this. It's been too long. Let me plug this in. I have another phone on standby just to feed some AI and feed AI this image. What is the angle? Question mark. Top side, bottom side. Assuming the trapezoid is a right angle at the bottom left, not parallel sides. About 46 degrees. Okay. So I don't think I need to do like how large the wings are, how thick they are. I don't really think that does me any good. Because I know one of the things that I needed to look for is whether or not they're rounded along the edges, but there's really no way I can tell if they're rounded. I don't know how obvious it is on this scale, but they look pretty squared to me. Then there's also another thing about the sort of typical Phillips, in that the recesses, sort of these valleys between the veins, are curved, where this one looks like it's pretty squared off at a 90 degree. That's also another thing I can't really determine. Like, you can kind of see it, but I can't guarantee that with any sort of objective measurement that I'm willing or I'm able to produce. So I'm not going to worry about the wing or the vein thicknesses right now. So let me swap over. Well, let me see if any of my junky screwdrivers here are actually on parity. This one looks pretty close. Okay, that one's good then. Well, this one's way too small. This one might be... Oh, maybe it is fine. It's just very tiny at the tip. This one does look a little bigger. What was this one? Oh, this one's the no marking. I might... These measurements might just be completely... Or just sort of eyeballing it right here might not actually mean anything. Because they could all taper down to the same point. But that doesn't mean they're the same screwdriver. Well, when I look at my... This is a 0. Yeah, so even my 0 tapers down to this same point. So that's not a good accurate means of determining what one is what. So AI determined this angle to be about 46.5 degrees. Maybe I'll have to look up how to do this measurement so I can do it by hand. So I'm going to move on to my next one, which will be this one. And really kind of looking at it, aside from sort of the actual tip being a bit mangled, like this. Let me see if my other 00 bit looks a little better. Those veins are a little chewed up. I've had to get a lot of stuck screws out with these 00s. About the same, really. I definitely wouldn't have a problem retiring these. Have it as a backup set. Because if sort of the conclusion of my research is anything to go off of, it's not so, like, the standards at which Phillips operate on, or any crosshead screwdrivers, they're all fundamentally the same nowadays. Like, either they all follow the same universal industrial standard, and the variance with it is just, are you buying quality tools? Because if this is a cheap tool, and if it causes me issues that more premium, so to speak, tools don't, it's not so much that the premium tools use a more fitting industrial standard, it's just that they're made at a higher quality, tighter tolerances perhaps. And it doesn't matter if they're JIS compliant, quote unquote, because JIS and any other industrial standards are all the same. The handle of my screwdriver is a little bulky, so I'm just gonna remove the tip. Go from here. I need to find the best vein to operate on. A little hard. It tapers kind of. That kind of works the best here. So let's see what we got. Now the vein diameter is going to be a little smaller. I know you could tell that visually. Might be 1.5 millimeters. That'd be a nice number. Yeah, I think it's about 1.5-ish. It's close enough that going to the hundredths I don't think is worth me measuring because I really can't guarantee accuracy at that degree. And there is there's a range at which this thing is even accurate. I don't remember how much it's off by. So my tool will give me a false measurement just based on the tolerances of this set of calipers and just me sort of literally eyeballing it. Granted, it is fairly accurate eyeballing. I won't discredit that. I'm gonna have to be very careful when I do the diameter measurement because it looks like the tip or the driver kind of tapers back in. So it looks like the tip is about 1.6 again. Yeah, I like that. That looked pretty good. Or 0.6 millimeters. Now like I was saying, it looks like it sort of peaks diameter right where the wing tips are, or right where the vein tips are, and then sort of tapers back in along the shank. So I'm gonna want to grab it right at the vein tips. And it's probably 2. Oh, turned it off. Quite hard working in a 3D space, only looking at a 2D image. Let me do this, just freehand it. 2. That was a lot easier. I should have just done that. No, not 2.5. 2. 2 millimeters. Mm. I'm gonna do this by hand. Not that I don't trust AI, but I don't trust AI. How do I find the angle? The angles in a trapezoid with known side lengths. I think I actually need images. Trapezoid angle calculator. Oh, Christ. I mean, like, gee whiz. I don't know angle D. I do have B, C, A, and C again. Okay, they have a calculator. Let's see. So A is 2 millimeters. I'm gonna do the first one again. B is that's not angle B, that's side B, which is 0.6 millimeters. Then side C is 2 millimeters. Solve. Oh, solve for base A. Oh, okay, I need to put in. I'm solving for alpha. Ah, so this one's a 61 degrees. I'm gonna trust this calculator. It's odd for it to be so different. Let me make sure I punched everything in right. Ooh, I'm glad I don't have to, yeah, I'm glad I don't have to do all this math because. So ABC. This one says 61.6 degrees, I'll say. Let me now adjust everything. Angle A will be 2. Angle B will be, again, 0.6. Angle C will be 1.5. Solving for the angle alpha. Yes, because I decided to care about that angle. 62.18. Huh. That's interesting for them to be very close, but not exact. Make sure I got those angles right. BA 2 millimeters, 1.5. Yeah, interesting. And that could just be factory tolerances, maybe. Again, I'm not very exact in my measurement, and I would guarantee that any damage caused to this head is not throwing me off by half a millimeter. That would be significant. But with tip geometry being off by what is this 0.8 degrees? I would say that's within like margin of error, or like within sort of a. Again, I can't even say tolerance because I'm only measuring to like the hundred or just the tenths. So I'm gonna get to this. So this is a reverse casting of a screw for the DSI. Now, reverse casting is I just poured hot glue onto the head of the screw. Or I poured a blob of hot glue down and dunked the head of the screwdriver into it. So I wanted to try and measure this. I gotta shave it away a little, though. Be a little hard. I don't want to damage the casting. Should be hot glue, so it should cut away pretty easily without damaging the impression left. I don't know how sharp this X-Acto knife is. It should still be fairly sharp. what I need to do is, because I need to get the height of it, it's a little 3D casting. I need to get the height of it. I need to cut away 2 sides so I can get my calipers in. I could probably get my calipers in right there, but I'm just going to be a little play it safe and get a little more. This will be a lot harder to measure. Especially since not only is it a little hard to see, I'm gonna have to sort of fudge it a little. And I also probably have to take into consideration hundredths measurement and just get it as close as I can within reason. Like, as much as I'd like this to be super accurate, there's really only so much I can do. I think I'm gonna need some tweezers for this, actually. So it does have dimension to it, which I'm going to want to try and get the height on it without actually taking into consideration the base of the hot glue. So I actually don't know if I can do... I did make these imprints on my, I don't like what I'm about to do, but what I think I have to do is sort of take the height measurement and then just subtract out the base, or subtract out the extra hot glue. That might be my only real meaningful way to do this. Upside down. And then there's also, I don't want to smash it. I might have to eyeball this, actually. Working on as much as the microscope's being helpful, I can't see in 3D space with it. That 1.42. 1.42 subtract 6. So its height is approximately 0.82. So I believe this is a trapezoid in shape. Again, I'm trying to look into the head of a screw, so I can't really say. I don't know how well the form is for that. Yeah, it is sort of that trapezoidal shape. Whether or not I'm going to be able to get the upper angle, I don't think I'm going to be able to get the tip of the trapezoid. So what I have, though, is sort of a height 0.82. That's, of course, at a right angle. So by I should be able to still get this angle even if I can't get this tip. So now I need to get the width. That's going to be very hard. I'm almost wondering if I can... Actually, I might have to cut away more so I can get my calipers over here without hitting this hump. I'm going to have to cut it all away. Ooh, the question will be, how do I hold it without damaging it? Right there. If I would have been a little more conscious, I would have cut these, or would have cut away this stuff in a way that would have made it so I had greater, or it squared up a little better. If I cut it right here, then it will leave me a little tail for me to grab onto without being too hard on the actual impression. There we go. Choosing a white background was a choice. Let me see if I can sort of contrast it a little better. Kinda. Not really, but, you know, gotta work with what I have. I would almost say 0.5, but I don't want to measure, or I don't want to round if I can't help it. I think I will say 0.5. It's very close in there, and it's a little hard to tell where sort of this side ends and sort of the base begins. So base is 1.5 millimeters. And I don't think I'm going to be able to get a side measurement, not anywhere close to accurate, just with how I have this impression, or the top. So I wonder if this is enough information. Try that calculator again. So I have angle H and angle A. angle A is 1.5. Angle H is 0.82. Solving for alpha, acute angle alpha. Do I have enough information? I think I do. Hello, website. Do you actually want to try and solve for that? No, I guess not. Angle A is 1.5. Angle H is 0.82. Solve. Oh. Error. You need 3 inputs to make a trapezoid. Shoot. The only other measurement I can try and gain is the top. The angle, the top of the trapezoid. That's the only one I can probably get accurately. If I didn't already, like, mush this. Ooh, that's going to be very hard. Using hot glue was definitely not the best medium for this, but this is what I had. So it's sort of like semi-translucent nature is making it very hard to see. Let me grab my sharper tweezers here. So it's basically, can I get that super, can I get that tip accurately? I really don't think I can. I can barely see it. What am I catching on? My pad. It's like, it doesn't directly come to a tip, but where it actually tapers off and flattens, it's a little hard to determine. What angle am I looking at this at? Head on down. Kind of like that. And it's really hard to tell. Because it does look like the screw actually does taper to a point. Somewhat. This is one of those times I wish I had a really accurate, or I was on a compound microscope, because I'd be able to see this a lot better. Digital microscopes can only get so good. I would almost say that is probably about close enough. I think that's the top of the trapezoid. 0.37. So will this be enough to calculate? So now I have angle B. 0.37. So this is approximate, like, this is definitely, this is for side alpha, which is technically on this side, but it's a mirror image. This is 55 degrees. From what I remember of reading Phillips's patent, these should be opposite, where the Phillips should be sharper than the actual screw. Because part of Phillips's original patent was when you push the screwdriver in, there will be a gap between these two edges that will push crap out of the screw. When you actually push it in, it'll cause a wedging motion to just shove stuff out. But that's interesting that it's a sharper angle. Of course, I'm sort of taking from a hot glue cast, so I'm not going to take that as gospel, but that is interesting. So I'm going to sort of hang on to those measurements and actually move on to the more practical demonstration, if it even is one. So when I've been working on these DSi consoles, I've never had a problem with cam out in the way that people suggest, or at least in the way I see it. People mentioning it in like the motorcycle forums, how they just mangle screws. Now, I've seen my fair share of mangled screws and probably have mangled my own a couple times, but a lot of it is just due to them screws being damaged. So let me grab a typical screw, find one that's not, that's in really good shape. This one's in really good shape. Not super yeah, no, that's actually a fairly typical screw head shape. And though, yeah, there is the thing about JIS screws where they have that dot. On all these screws that are just so tiny, I don't think they put in that dot, and that dot is never a good indicator anyway, because it's not on every screw. So what I want to do is just get my screwdriver and just screw this in normally. It is going to punch through the shell, but I don't care about this shell. I just need to know if there is a cam out action like described. I'm going to back it up so I'm at least trying to go into the threads of the shell. Why isn't it? There, it just skipped. So that is the camming out action that people talk about. So let me go back out. I was putting it in pretty snug. More or less snug than I would originally do. I actually don't know. I was more watching and not so much paying attention. I was going in there pretty snug though. So let me try my vessel, which is not magnetized, which is annoying. Anything this small should be magnetized. That's why I don't really use it that much. I can try and magnetize it again, but that's another problem. So this one isn't camming out. Like, I'm torquing it pretty hard. There, it finally cams out, but like, I was pushing that in really, really hard. Let me just sort of observe the fitment of this. So it does fit in those recesses very good. Where this one also looks like it fits in those recesses very good. It looks a little different just because of how, but there's a little bit of play in the Phillips. Is there this much play in the vessel? No, not much at all. So maybe vein width is a little more. And that cam out action is in line with anecdotal evidence, even if it's not like patented, or if that's part of the patent. Which Phillips patents was fairly clear that that is not an intentional feature of a Phillips screwdriver, is to cam out like that. His original patents were very clear that that's not the intention, trying to avoid it. I'm interested to see if this vein is sort of a different size as I go up the screwdriver shaft, which it is. It sort of flares out right at as close to the tip as I can. It's like about 0.3 millimeters. Just call it vein 0.3. The tip of the vein, it might just be how it tapers out. Perhaps, like maybe this tip is going to be exactly the same, but it will taper out less aggressively than the vessel. Because it's about the same 0.6. Or it will probably be 0.3. Well, goes a little more, so let me just sort of push it along my calipers. Goes all the way to 0.8. Well, what I was seeing with that screw was not sort of made up. There was enough play. What would that play be? It would imply that these veins are shallower. Possibly, if I do just sort of like an arbitrary going up just a smidge, at 0.4, like right here. No, so yeah, it doesn't taper as aggressively. The only way I could really get a slope is if I sort of measured down the screw and sort of made an arbitrary point at like a millimeter down, which would be kind of difficult. I might just eyeball it, because what I saw implies that these veins are the veins on my Phillip. They might be the same point, but they don't slope out as aggressively. The full length would eventually be 1.4, and I know my vessel is a little thinner. Let me see if I can incorporate my screw, or try and see if I can get that length. Try and see if I can get sort of an arbitrary point going. This might be a little hard, because though I can remove the tip from my Phillips, I can't remove it from my vessel. As cool as that would be. So if I do 1 millimeter down, so it's 0.3 at the tip, what is it at this 1 millimeter down point? My camera is not going to help me. I need to get it angled so I'm not going to hit it with my calipers. So basically, what's the vein? Right here. It's about 0.42. So what I need to do is sort of visualize this for me. So vein, the vein is also sort of a trapezoid in its own sense. So I'm going to guess it has mostly a flat tip. I'm trying to think of this in a weird 2D shape, so it will probably, oh yeah, okay, so it will sort of, it'll look something like this. So if I do a span of 1 millimeter, we have a thickness of 0.3, and then it was a thickness of 0.43. Yeah, so maybe it's because I'm not going up high enough. What if I do 2 millimeters? I got 0.44. That's 0.61. Oh yeah, look at that. So when I go, we're talking about like point 0.1 or so millimeter difference. I need to actually write these down instead of just sort of winging it here. About right there. That's 0.43 again. So it sort of doesn't taper anymore. Hang on. Is my measurement wrong? 0.33. 0.43. Weird? 0.35. Okay, I guess I did this wrong. .35 and the angle of 2 millimeter deep. This is difficult. Right there, 0.43. Okay. Okay, let's try it on the vessel now. Remeasure. Get it squared up as best I can. One millimeter down is 0.46. So yeah, it is tapering far more aggressively. Gonna do some rough drawing there. Now let's do 2 millimeters down. Approximately. About right there. 0.65. So it is tapering down far more aggressively than my Phillips head. I'm trying to sort of figure out why. Like, why would that shouldn't impact cam action? I guess if it is a little loose, it does have, it's not as snug. So I need to find the slope of a trapezoid, basically. I wonder if I can... Let me see if there's any way I can calculate that. It's not side. Slope of a trapezoid. Slope of a trapezoid. Math is fun. Wait, if slope is just rise over run... I just need to make sure I remember my math correctly, because I'm a little removed from that. Well, actually, it doesn't need to be an exact triangle because I can just cut it in half. Right angle right there at 0.5. But it's not, it would still be a trapezoid. It would just be a real strange trapezoid. Oh boy, okay. I need to take back what is slope. It's rise over run, I think. This is called rise over run. Yeah. Oh, Lord. Okay. So if the rise is 2 millimeters, I think it would look a lot sharper on a trapezoid than, well, if I just do rise over run, that would assume like a right triangle. Slope of a trapezoid. I give up. I'm not really finding anything, and I don't want to dig too deep into these math articles. But the slope is, what, about doubled? Give or take my sort of janky measurements from my vessel to my Phillips. It's about a doubled slope. Which I guess would explain why it fits so loosely. Let me sort of get my little test rig up again. Hopefully I'm not damaging the screw. A little bit. Let me try and get it a little more straight. Come on. Supposed to be self-centering. So yeah, that would explain why there's a jiggle. There's play in the screwdriver head. But I've never really had a problem with this screwdriver. So I'm screwing it in. That's where I would probably stop. I would think that is snug. If I go a little tighter, which right now it's like, wow, I'm really torquing it down, then it starts skipping. So there, it's camming out. And it's not crazy snug. If I push down, I can go a little more. But at the pressure I'm at, I start camming, which will damage these screws. Yeah, it's already starting to eat away at it. Where if I go directly into my vessel driver, I can't really get any more rotation out of it, but it's not camming. So I'm going down, down, stops. Like I would stop right there, like that's snug. That's even probably a little more snug than my Phillips. So that is interesting. I don't really recall camming out on my drivers. Now let me try these junky drivers. Snug fit. And I would think that maybe because my Phillips came out of China, it would be a little bit of play in it, I guess. As I screw down, I'm not camming. And again, it could just be because my Phillips driver has gone through the ringer and it's damaged. I'm not going to rule that out as a possibility, not just because, aha, Phillips. Yeah, this one's just flat out too big. I think this one's too small. Okay, too big as well. Okay. So now that I've sort of determined the biggest difference between these two screwdrivers is sort of the angle of these vanes. It could be because the ones on my Phillips are rounded, which allows that cam mount action, or it could just be because it's not fitting in there super snug. I didn't mean to take this all the way out. So if I were to screw this in normally... Ooh, even jumped right there. Like, that would be good. So, wow, so that would mean that I've been damaging these screws. Well, that sucks. Because that's a good snug fit. I didn't cam once. And another key factor is it's not because of lack of pressure. This vessel driver is much lighter than this for hopefully obvious reasons. There's far less material. So there is more weight going down onto this screw head. I'll try and sort of limit my downward pressure on it. Yeah, it just skipped right there. Right now it's grabbing it pretty good. There it skips. Huh. Do I need to hold my shell? So I can try and just sort of stabilize it and just only use the weight of the screwdriver. So I'm just holding it vertical and then twisting it. Ooh. So I am able to get it. Again, I really haven't had much problem, or maybe it was just because I'd never noticed the camming. Or just thought that was normal. But now I'm not having much problems. It's odd. But there is that... I do objectively have measurements saying that the vanes are not big enough. Or maybe that's not even... Does that even matter? Because I'm determining from 1 millimeter down based on my cast. I never measured the wings of my cast. What is the actual width of it? Or what are the width of the vane at 1 millimeter? Well, in this case, it won't be 1 millimeter, but close, sort of close enough. So I did the entire screw head, and I guess the screw head only goes down about 0.8 of a millimeter. Okay. Ooh, this will also be very hard. Again. Don't want to squish it. Oh, I think I may have cut it, actually. A little hard to say. It's about 0.3. Oh, I shouldn't be. Try another angle. That looks good. 0.32. That begs the question, if it is 0.32 at about a millimeter, then the vane of the Phillips should be perfect. I think because the head is wider, maybe? It's 0.37. And we're not exactly at a millimeter. So it's 0.32. at the approximate depth of 0.82. So adding that 0.2 millimeter might, I don't think it would take it all the way up to 4. But the tip itself is not 0.3, actually. This will be a fun measurement to try and take. Wow, my microscope is effectively useless on this type of job. Yeah, I don't know if I'm going to be able to even get the tip accurately. Maybe it's 0.3. I think that's the best I can do. So will it make it up to will it taper up to 0.35? Sort of visual evidence would suggest it tapers up more aggressively, up to about 0.46. Or maybe because there's also the thing about, I think another one of the arguments for Phillips and JIS is that the actual like tip of the screwdriver is pointed. I can't really determine that. It kind of looks like it, where JIS is flat. And because my Phillips head is damaged a little, kind of looks like it comes to a point just a little. There's no way I'll be able to measure that. Huh. The results do speak for themselves. This vessel driver does work a lot better with these screws. It holds onto them. And it doesn't cam, which is important because, oh, you know, I should stop making grandiose statements like that. Well, now it's just because this screw might be a little damaged. Just going back and forth. So far, I haven't cammed out once. I'm sort of using what I'm kind of in an awkward angle where I usually would sit, but I am putting about the amount of force I would if I were screwing in one of these screws. I'm just going until basically the screw stops. Not so much like a predetermined like torque, just whenever it stops rotating with relative ease. Okay, let me try the same experiment Let me make my shaft a little longer. Giggity. I'm basically backing out the screw until it actually becomes loose, and then I back it out and I turn it counterclockwise until it clicks. When it retracts onto the threads of the plastic, so I'm not stripping the screws, cross-threading it. And this is, yeah, as I'm showing, this is why I've never had a problem with my Phillips driver. Like, I'm screwing in about as much as I would, the pressure I would usually do. I go until the screw stops. I'm not doing anything unusual with this screw. Like, I'm not, like, to say that I have, because I'm experienced doing this, I'm not doing anything too different. Sure, I did show that it does cam out, but I was kind of going under like very specific, like almost like test conditions where I would over tighten on purpose, because I wouldn't go more tight than this. There's no point. I'm pressing in about as hard as I would putting in these screws, and even my like damaged Phillips isn't creating that cam out action. So really the only conclusion that I can draw from all this is, well, my JIS, which I put in air quotes because I don't know what standard vessel follows at all. They do mention JIS. Their English website even mentions JIS Drive Plus as sort of their guiding standard for tips, but JIS Drive Plus doesn't mean anything in industrial language. It's just marketing baloney. But considering that vessel, whether or not this thing is actually a fake, I don't know, actually. But if this is an authentic vessel, which other than the letterings rubbing off, I really don't have any reason to believe it's fake. If this was catered more towards JIS screws, it is showing for it because it has a nice snug fit. No play within the screw. Like, it is real nice and snug in there. And compared to this Phillips, which is just marketed as just Phillips 00, which again, by my rough measurements that I've taken, have different angled philosophies. Let me get this snug. Because the taper of the vanes is definitely not as much, so there is play. And it could also be that this is now out of spec because of how damaged, or because it's damaged. I'd have to get a brand new set of drivers to really test that. But there's just some measurements about these driver heads I can't take. Like, I don't know if these vanes are rounded off. There'd really be no way I can tell just from a... Like, if those are square down or if they're rounded off, I wouldn't really be able to tell. Yeah, so I don't know. My Phillips, because I'm guessing maybe because of this how it tapers, not as aggressively as the vessel, that probably increases the chance of it camming out because it's not as snug of a fit. Maybe because it does have a bit of a tip on it and it's not, or a bit of a sharp tip and it's not going into the screw hole as deep as the vessel does. Really is. It's a head scratcher, I'll say that, because yeah, what this tells me is what I already know, is really what I'm I'm unsurprised at. Other than like the raw measurements, which the tapering is interesting. I didn't know that. But it sort of plays into the narrative that the JIS, quote unquote, does fit into JIS screws better than just a Phillips. Phillips have the tendency to skip. And that's sort of in line of what I've heard. But the question I'm trying to ask is why? Why do why is that a thing? And the answers I've been seeing are just not very satisfactory. So, other than just having some more anecdotal evidence to add to the pile, there's nothing really I can glean from this. Because even the recess, like, I'm not going to take the cast data to, like, as gospel. I don't even know where that cast ended up going. Flicked it somewhere. Oh, I think here it is right here. Doesn't really matter. I don't think I can really trust these measurements, so to speak. But there might be something to it where if the cast is sharper, like if the actual screw hole is sharper than something like this Phillips, then that would explain why the Phillips can't nestle into the screw head as deep as the vessel, since the vessel is a tiny bit narrower. We're talking, what, 0.8 degrees? And the fact that the veins don't taper as aggressively as the vessel might signify just a better marriage between these 2 points. It could be I'm completely misinterpreting all of this and a 0.8 difference of degree is meaningless, that the vein tapering is far more impactful. Or like I was saying, how there could be like a tip, like maybe like a 20 degrees tip on both of these screwdrivers, or maybe more aggressive, less aggressive, which means it won't sit deeply. So instead of it being a trapezoid, it's more like a trapezoid with a even sharper angle triangle on top of it. So it's not flat. But it's a consequence of me looking at stuff this small. If I was really smart, I would be looking at this at the biggest scale I can possibly get. Like a number 2 screwdriver, a number 2 JIS screw, a number 2, like an actual marked JIS screw. And then 2 new drivers, one that says they're JIS compliant and another that's just a Phillips. Yeah, I don't know. I'll have to chew on this for a little bit and see what else I read to see if that sort of falls in line with the other anecdotal evidence that suggests this, as well as anything else. but it's kind of good to have an idea. Like, again, I'll still keep using this driver because it has the magnetic tip. I can swap out tips. And just the way that I've learned to use it, I don't cam out in the way that anecdotal evidence would suggest, like, yeah, you're going to cam out all the time. And yeah, that all that anecdotal evidence is again coming from the motorcycle sector, which maybe they have higher torque requirements than a screw going into plastic. That muddies up the conversation a lot. I'm definitely going to have to, because there really isn't much conversation in the sort of precision screwdriver world. The only thing I have been starting to find was the camera, like the camera sector, the camera hobbyists who get cameras out of Japan. They're the ones who talk about JIS as well. Definitely not as loudly, or maybe their forums aren't as active as motorcycles are. I don't know. It's interesting. I'm gonna have to chew on it a little more and keep doing some reading. I'm definitely still in the throes of research as far as this topic is concerned, but as to why why there hasn't been a clear cut answer is because of how complicated it is. But okay, yeah, I'm gonna stop babbling and call it good on that.